Hello everyone. Welcome to the course Principles and Applications of Mechatronic Systems. I'm your instructor, Jam Shinja. Today we'll study Chapter 2, Fundamentals of Automatic Control, Simulated Closed-Loop PID Monitoring. As a key technique in the field of automatic control, simulated closed-loop PID monitoring has revolutionized traditional industrial process regulation, providing strong support for efficient and precise modern industrial operations. What exactly is simulated closed-loop PID monitoring? What are its working principles and practical values? Let's explore further. Introduction to the closed-loop PID monitoring project. Based on the importance of temperature control in the baking oven of a biscuit production line, temperature PID control can be implemented using Intelligent Instruments PIDs or PLCs. To enhance informatization and intelligence in control, a DCS architecture is adopted. The system includes engineering and operation stations, switches, and S7-1200 control stations, including CPU and signal I or O. The field control layer includes sensor transmitters and actuators connected via TCP or IP. A transmitter-free wiring diagram, preferred solution, is demonstrated, which includes intelligent PID controllers, solid-state relays, resistors, sensors, etc., with two wiring methods for AC 220 volts and DC 24 volts power supplies. Let's first look at the project breakdown. PID simulation. Based on S7-1500, the 1500 PID simulation object library is used to understand and apply PID in theory. PID closed-loop control based on PLC application system, applicable to temperature, wind speed, or water tank modules. Oven monitoring project implementation uses configuration software such as KinView or TIA Portal Visualizer, WinCC. 1. PID simulation. Basic steps covers PLC hardware configuration, PID function block creation, parameter setting, PID parameter tuning and uploading, simulation startup, and object block creation. S7-1500 PID simulation architecture uses the PID_compact controller and the controlled system from the LSIM simulation library to form a closed loop with step response curves and related output parameters. Specific operations. Create and configure the PID function block. Create OB3 cyclic interrupt organization block. Add simulation object modules. Start simulation. Perform PID debugging. And adjust PID parameters. 2. Steps to realize PID closed loop control based on PLC application system. Implementation steps. Configure the S7-1200 application system, including hardware and network communication, especially PID application configuration. Power on after completing hardware installation and wiring. Download configuration. Analyze S7-1200 project operation using monitoring tables. Conduct PID auto-tuning and application. Upload PID parameters. Refer to the simulation. Key implementation points. System installation. Creating an S7-1200 project with TIA portal, hardware configuration of the control station, software configuration and development of the control station, debugging, monitoring, operation, and analysis. 1. Control station software configuration. S7-1200 control station software uses PID instructions to control temperature by sampling temperature values at timed intervals and calling instructions to drive the solid-state relay and electric heating plate. Includes placing the PID function block in OB30 loop, process object configuration, PID debugging, and auto-tuning. 2. Pure PID control debugging, monitoring, operation, and analysis at the control station. 3. Closed-loop analog control visualization based on TIA portal. Create and debug an S7-1200 project using TIA portal and complete configuration screens including start screen, main screen, historical trend screen, and a long screen through TIA portal visualization. PID configuration of the control station includes adding cyclic interrupt organization blocks, adding PID process blocks, configuring PID parameters, and tuning PID parameters. 4. Key points in operator station configuration with KingView plus S7-1200. Configuration key points. Device definition, S7-1200 Ethernet, communication and connection configuration, real-time database variables, flexibly adjusted as needed, referring to the PLC memory unit parameter relationship table, with simplified, complete, and self-customized versions, screen configuration, multiple screen divisions, mutual switching, trend curves, alarms and safety-related settings, debugging, monitoring, operation, and analysis of the control station. That concludes this lesson. Thank you for listening. See you next time.